This is CPM Calculus, Chapter 3, number 186. Write a Riemann sum to estimate the area between our curve f and between 5 and 13. For f of x is defined to be 4 times the cube root of x minus 5 using n left endpoint triangles. Then calculate the area for n is equal to 8, 20, and 50 rectangles. Which is most accurate and why? Alright. So remember to find the area between our function and the x-axis between x is 5 and 13. So we approximate that using a Riemann sum, right? And we start with n is equal to 0 to, oops, not n, I want to use a different variable. Let's say k is equal to 0 to n minus 1, right? And then we basically are going to use rectangles, so then we want it to be base times height of every rectangle, okay? So what is the base of every rectangle? Well, we know the base is going to be the width, right? The width of this region, 13 minus 5 units, divided by how many rectangles we have, which is n. All right, so 13 minus 5 is 8. So we have the base is 8 over n. And the height is just going to be our function's value, right, is going to be, h is just going to be f of x. And then we're going to add 8 over n for every k. Okay, so it's going to be like this. So let's go ahead and plug that in. So the area is approximately, starting k is equal to 0 to n minus 1. The base again is 8 over n. And the height is going to be our function, right? Our function of x. Well, where are we starting? We're starting at 5, so let me even change this x here. We want to start at 5. Get the pen back. Right, we're going to start at 5 and go all the way to 13. So we're going to start at 5 and each time add 8 over n times k. Okay, so because we're given f of x, we can even write this function out, right, in terms of the actual expression. So k is equal to 0 to n minus 1, 8 over n. Well, what is f of 5 plus 8 over nk? Well, we're just going to plug that input, right? And so everywhere we see x, it's going to be replaced with this. So that's going to be times 4 cube root. Right, 4 times the cube root of x. Well, instead of x, we have 5 plus 8 over n k minus 5, right? We can simplify that a little bit. That's just going to be sigma from k equals 0 to n minus 1, 8 over n times 4 times the cube root. And 5 and negative 5 cancel out, so we just have 8 over n k. All right? So, let's go ahead and let me just see. Yes. So that's what we have. So we want to calculate the area for n equals 8, 20, and 50, right? So let's go ahead and do this. For n is equal to 8, right? Then we have the area is estimated to be the area between f and, what was it, 3 and 5 and 13. Right? Then it's approximately k is equal to 0 to n minus 1 is 7. Right? 8 over n, so 8 over 8 times 4 times the cube root of 8 over 8 times k. Right? And that's the same thing. I could just write it a little neater, so I could plug in my calculator, and it will be faster. Starting at 0 to 7, 8 over 8 is 1, times 4. Cube root, I'm going to write as the power of 1/3, right? 8 over 8k is just k. So let's bring out our calculators, right? Go ahead and turn it on. We want to go to our catalog and get the sum function, right? using sigma, the expression is 4 times k. Where is k? K is alpha above EE, right? 4k to the power of 1/3. Okay. Then my variable is k. And my low is 0. My index starting is 0. And I stop at 7. Okay. I put equal. It's going to give me it like that. So I'm going to go ahead and approximately get the answer using the alpha green key. Or not the alpha, the green diamond. And I get the area is approximately 42.9184 units squared. Because we're looking at area, so remember it's units squared. Okay, so let's go ahead and do, for n, we want to look for n is 8, 20, and 50. So for n is equal to 20, the area is now approximately, I'm going to write this again, instead of k being, n being 8, we have n being 20, so we're going from 0 to 19, and we have 19, we have 8 over 19, 8 over 20, I'm sorry, I should be looking here, I was looking here, so we have 8 over 20 times 4 times the cube root of 8 over 20k, okay? So I can put it in my calculator like this, except I want to change the cube root to be to the 1/3 power. So let's just put it in the calculator. So again, we do the sum, right? Go to catalog. Oh, get the sum. The sum and our expression is 8 divided by 20 times 4 times the cube root. So I'm going to put it in parentheses. 8 over 20 times k. Times k. Oh, why is it doing that? Am I pushing? Oh, I should be pushing alpha. Okay, times k to the power of 1/3. Okay, comma, our variable is k, and now we're going from 0 to 19. 0, 19. Okay, let's go ahead and just get the approximate value, and that's 46.0775 units squared. Okay, so let's go ahead and do, for n is now, we're going to do 8, 20, and 50 rectangles. Okay, so let's just move it over to the right a little bit. Alright, so now for 50 rectangles, right, n is 50, so we have the area between f and 5 and 13 being approximately now, n is 50, so we go to 49 starting at k is 0. I'm going to just copy this using n is 50. 8 over 50 times 4 times the cube root of 8 over 50 times k. Alright, let's plug it into our calculators. Catalog, get the sum function. Now we have 8 over 50 times 4 times the cube root of 8 over 50 times k. Right, so the cube root is going to be the power of 1/3. Right, again, my variable is k. I go from 0 to 49. Right, I'm going to get the approximate value, and that is approximately 47.2643, again, units squared, because we're looking at the area. Okay, so here is my approximate area when we have 50 rectangles. Let me put away the calculator. here it is when we had 20 rectangles, and here it is when we had 8 rectangles. Okay? Let's go back to the question. Let's answer the last part. Which area is most accurate and why? Well, remember when we're approximating the area and we're using rectangles, the more we put, the closer we're going to actually get to the actual area. So as n goes to infinity, right, increase the number of rectangles, we will approach our actual area. So which one has the biggest number of rectangles? So using 50 provides the most accurate results of the three. Of the three results we have, 42, 46, and 47.2643 units squared. Alright, so that ends CPM Calculus Chapter 3, number 186.